Hello, boys and girls. Welcome back to another edition of Crush Lusher Television. All right, we are going to review today differentiability. And so we're going to do differentiability Chiles scrimmage. We got hot, we got medium, we got mild. We got all these. So this is in the PDF that's attached. So pause the video, write this down. So we're going to do the mild, then the medium, then the spicy. Then we're going to practice them. That would be on the AP. All right, here we go. Let's write it down. Hopefully I wrote it down. There it is. So here's the mild. Okay, so is f of x differentiable at x equals 1? So the first thing we gotta do is draw our wedding cake. The first thing that's got to be true is there has to be a limit at x equals 1. So there can't be no jump or anything like that. There has to be the same x and y, same y value as you approach 1 on both the left and the right side. Then what else do we have? We have to make sure it's continuous. Or continuity, you can write it down. Sorry. Boom. Write a little U in there. So make sure that not only we're approaching the same y value from the left and the right, but there's also a point there and not a hole. So that's what the continuous is for. And the next thing is we're going to make sure we have the derivative is the same on the both sides. So we don't have a cusp like that or a undefined slope or anything like that. We have to make sure that we have the same slope going from the left and the right. All right, so start at the bottom. So boom, now we're here. 1, so the limit. So the limit as x approaches 1 from the left of f of x, does that equal the limit as x approaches 1 from the right of f of x? So no problem. So the limit as x approaches 1 from the left, that would be here, because when x is less than 1. So that would be limit as x approaches 1 from the left of f of x is 2 times 1 to the 5th minus 7 times 1 to the 3rd plus 1. Which when you just have 1 to the 5th is just 1. So it's just 2 minus 7, which is negative 5, plus 1, which is negative 4. Boom. Cool. All right, so the limit as x approaches 1 from the right of f of x. X here, because that's greater than 1. So approaching from the right, you're on this part. So it's negative 4 times 1 to the 3rd minus 7 times 1 squared plus 1. Okay. So we have negative 4 minus 7, which is negative 11, plus, sorry, this is plus 7. 7 right here. Negative 11 plus 7, which is also negative 4. Ding, 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 ding. So therefore, 3 dots mean therefore, like that. A little triangle formation. Therefore, the limit as x approaches 1 from both sides of the function is negative 4. Cool. So you're approaching negative 4 from both sides, but step 2, do we have a hole or not? I don't know. That's what we got to find out. Does it equal the actual point, or is the point somewhere else? So it's like here, the point from the left and the right, we're approaching negative 4 from the left and the right, we got that. But is the point up here or down here? It has to be right here at negative 4. Let's see. So f of 1, where does it equal 1? I look at the domain. So equals 1, so that would be the bottom. Yeah, you did this already. You still have to write that. So f of 1 equals negative 4 times 1 to the 3rd minus 7 times 1 squared plus 7, which is negative 4. Ding, 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 ding. So this is also true because we proved this is negative 4 right there. All right, so now we're going to make sure we have differentiability. We don't have anything like this on the graph. So third step, does the derivative as the function approaches 1 from the left, oh sorry, it should be inside the properties, 1 from the left equal the derivative as we approach 1 from the right. Okay, so 1 from the left, up here, so we got to find that derivative. So that's going to be 10x to the 4th, sorry, f prime of x to the left. So x from the left is 10x to the 4th minus 21x squared plus 0, right there. Cool. So now I'm going to plug in 1. So it's going to be 10 times 1 to the 4th minus 21 times 1 squared, which is going to be 10 minus 21, which is negative 11. There you go. Okay, next one. So now I want to find the derivative coming from the right. So that would be this part right here. So I find the derivative of this. So power rule, negative 12x squared minus 14x plus 7. Now I'm going to plug in 1 over bop. So that's going to be negative 12 times 1 squared minus 14 times 1 plus 7, which is negative 12 minus 14 plus 7. Negative 12 minus 14 is negative 26 plus 7, which is negative 19. Cool. Uh-oh, you have a different slope on the left and the right. F prime means slope, right? So this is no. F of x is not, I'm sorry, it is continuous, it's not differentiable, not differentiable at x equals 1 because, this is my justification right here, the derivative, the slope coming from 1 to the left does not equal the slope coming from 1 to the right. Bam. Cool. There we go. And here's my proof. Da 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 da. All right, now we're going to do the medium. Cool. All right, so this one, pause the video, see if you can do it. Try it. All the steps. All right, let's do it. Here we go. 1, we got the limit as x approaches 1 from the left of g of x. Does that equal the limit as x approaches 1 from the right of g of x? Okay. So the limit as x approaches 1 from the left of g of x is here. So that's 15 minus 5 over 1, which is 15 minus 5, which is 10. Cool. The limit as x approaches 1 from the right of g of x is 10 times radical 1, which is 10 times 1, which is also 10. Ding, 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 ding. Therefore, the limit as x approaches 1 from both directions of g of x is 10. So we're approaching 10 from both directions on the y value. Step 1, cake, done. Next, continuity. The limit as x approaches 1 of g of x has to equal g of 1. Make sure that point is there. Okay, so g of 1, look at your domain, 10 radical x. Okay, so it's right here. This is where it equals 1, and so I'm plugging in there. So g of 1 is 10 radical 1, which is 10. Ding, ding, ding. This also equals 10, so this is check. Cool. Hot place. Here we go. Okay, so I gotta find the derivative of 1 from the left has to equal the derivative of 1 from the right. Does that equal? All right, so 1 from the left is here. Ooh, so I'm gonna rewrite this. So derivative of x to the left. I'm not gonna plug in 1 yet, that's why I'm writing this. So it's, first of all, it's just 15 minus 5x to the negative 1. I can rewrite it here. So then I can find the derivative. Derivative of 15 is 0. And so negative 1 times negative 5 is 5. Subtract 1 here, x to the negative 2, which is 5 over x squared. And when you plug in 1 there, you have 5 over 1 squared, which is 5. That's the slope coming from the left. All right, now the slope coming from the right. Let's see, x. So coming from the right, coming from the right, x is greater than 1, so that's 10 radical x. So let's rewrite that thing as 10x to the 1/2, and then you can use your power rule. So that's going to be half times 10, which is 5x, and then subtract 1 is a negative 1/2. Cool. So that's 5 over radical x. Because the negative exponent brings it down to the denominator. 1/2 and radical is the same thing. All right, so now g prime of 1 from the right, which is 5 over radical 1, which is 5. Got it. Cool. All right, so here's your proof. Little statement. yes, g of x is differentiable. So many letters at x equals 1 because you gotta do the last two. So you gotta say when it's true, you have to say the last two. Say it's continuous, which is this statement here, and you have to say the last statement with the differentiability. So that's g prime of 1 from the left equals g prime of 1 from the right. Cool. There you go. Hopefully you got that. Nice jobby job. All right, where are we at? Cool. All right, last one. Here we go. Hot. All right, so find a and b, so h of x is differentiable at x equals 1. All right, cool. So what you essentially are doing is the limit as x approaches 1 from the left of h of x, and the limit as x approaches 1 from the right of h of x. So when you have stuff like this with the variables, you just have to know that the y value has to be the same for it to be differentiable, or for the limit to be the same. That's the first thing. So that would mean that when I plug in 1 here, it has to equal the same as when I plug in 1 here. And so that's going to be 4x to the third plus a equals b over x squared when you plug in 1. So I'm going to plug in 1 here. 4 times 1 to the third plus a equals b over 1 squared. So that's 4 plus a equals b. So I'm still can't do this because I have two variables. I don't know what it is. So I need to come up with another equation. Well, you also know the continuity part doesn't really matter here. But to be differentiable, the derivative as you approach 1 from the left, the slope, has to be the same slope from the right also. Sorry, prime here. So from 1 from the left is this. So the derivative of this has to equal the derivative of this, just like we've proven, right? So that's going to be 12x squared. A is just a number, so there's no derivative there. And then this is the same as bx to the negative 2. So that's going to be negative 2 times b. Like if this were 2, I'd multiply it together, right? So it's a negative 2b x to the negative 3. Then you plug in 1. So it's 12 times 1 squared equals negative 2b, and this is 1 to the third on the denominator. So that's just saying 12 equals negative, oh my goodness, now I can figure out what b is, oh, and plug it in, I got it, cool. So with the limits being equal and the derivatives being equal, when you plug in 1, that's how you can find out what value a and b are to make it differentiable. So divide by negative 2, negative 6 equals b. So I'm plugging that in here. 4 plus a equals negative 6 minus 4. A equals negative 10. So a is negative 10 and b is negative 6. Cool. All right. Now, this is what you got to do. Good work. Okay, so scroll here. So I want you to start here at number 4, 5, 6. Nice Roman numerals, huh? 7, no more Roman numerals, 8, 9, 10, 11. So I want you to do all those. So go all the way to 11. So go from 4 to 11 here. See if you can knock all those out. And in the form, if you get something wrong, or if you're confused, let me know and I'll do another video on it, okay? This is excellent work. See you soon. Good work.